Okay, so there were a couple of things where we were talking about when to use logarithms. And again, they're not really part of this class. So if you just want to use guess and test, totally fine. But let me explain them for a second. We'll come back to this guy in a second. The way logs work is if you have, say, 2 to the 4th power, which means 2 times 2 times 2 times 2, 4 times, you get 16. And the problem is happen if we have an exponent up here. Like if I have 2 to the x, you know, you'd have to just guess and test. You can't just solve exponential things. But what you can do is kind of in a way make them linear. And the way we do that is we take the log of the answer divided by the log of the base, and it spits out the exponent. But you can only have these 3 parts. So are you okay? This is the base, this is the exponent, and that's what I'm calling the answer. And so if you have those 3 parts, base, exponent, answer, the basic parts of something that has exponential with numbers, then you can solve it, all right? So for example, if I take log of the answer, so log of 16, divided by log of the base, which is 2, I can solve for the exponent or x. So I can take, and if you can use the natural log too, the ln guy or the log guy, doesn't matter, except you have to be consistent. So I can take log of 16 divided by log of 2, and I get the exponent 4. Or I could do natural log of 16 divided by natural log of 2, and I still get 4. Doesn't matter. These are logs that are based on exponential powers of 10. These are exponential powers of the e guy, that 2.7 guy, so it doesn't matter. So notice I can now figure out how to get that x kind of down low, like get it down here. But again, a lot of times, like when we did exponential growth, you know, like you have some other numbers there. So like say you start out with, I don't know, 20 people with some, I don't know, like COVID or something like that, and maybe it's spreading at 5% all the time, and maybe you want to know when does it equal, say, 2,000 people, and I don't know if this is every hour, every day, whatever. Okay, so you have a starting amount, you have a multiplier, and then you have this. So the problem is, do you see how there's 1, 2, 3, 4 things, right? There's the base, exponent, answer, but there's this extra starting amount. So what you have to do is you have to get rid of that first. So then I have 1.05 raised to x, and this is going to be what, 100? Okay. Now I'm ready because I have my base, exponent, answer. So log of the answer divided by log of the base will always spit out your exponent. In this case, my x. So I'm going to take log, it's spitting out the answer of 100. I know my base is 1.05, and it's going to spit out my exponent, which is what I want. So I'm going to take log of 100, oopsie, divided, well, maybe if I could type, how about log of 100 divided by log of, what was that, 1.05? And then it's going to tell me it's going to take 94, so about approximately 94.4 time periods. Now, that might be daily, that might be weekly, hourly, I don't really, know the context to figure that out. Okay, so if it's daily, like if the 5% infection rate daily for COVID, we started out with 20 people, when is it going to equal 2,000 people? It's going to take 94.4 days for that to happen. Okay, so now that we're doing finance formulas, okay, so let's look at this one. All right, so it's a lump sum of money. Everyone, okay, there's not a payment. This is a lump sum. It's a chunk of money. So we know we're over here, right? Okay. It says compounded, so we're definitely not doing simple interest, so that guy's out, right? And then it's not continuous, and it's not comparing interest rates. So it's a 50-50 chance between these two. This is when you want to know the future value of money. This is when you have a goal and you want to know what you need to invest today. Well, I know what I have, actually, and I know what it's growing into. So I'm trying to figure out time. So I actually know A and P this time, so I'm going to use a simpler formula. So I have A equals P, 1 plus R over N to the NT. All right, so the amount that you inherit is the amount that your principal. Interest rate, now again, this is, you might not, sometimes interest rates are written with fractions, so this is really 8.25%. You still have to move the decimal 2 jumps. It's 0.0825. It is compounded quarterly, which means N is 4. And this is quarterly times time. So N is 4 time is, ooh, that's the question, right? And how many years? So I don't know time. So I'm going to do 4 times t. And then it's going to spit out the amount of money with interest, which we know in the future it's going to grow to 20,000. We just don't know when. We don't know t. All right, so I'm going to just do the math in the parentheses. So I have 20,000. I have my starting amount of 10,000. And so I'm going to do this math to really actually figure out my multiplier. 0.0825, and it's quarterly, so I'm going to divide by 4. Oopsie, I think I screwed up my parentheses there. Yep. Okay, I think I can just delete that. Okay, so 1.020625. And this should remind you of when we did exponential growth. Starting amount, multiplier, exponent, and then it spits out the value. Okay, but there's 4 parts here, and I only need 3. So I got to get rid of the starting amount. So I'm going to divide by 10,000 and get rid of that. So I get 2 equals 1.020625 raised to 14. Now I can use logs because I have base, I have an exponent, answer. I don't have that extra starting amount that exponential has. Okay, so now I'm ready. Log of the answer. This is my answer. This number right here is my base. This guy up here is my exponent. So I take log of the answer divided by log of the base, which is all of that. And it spits out my exponent. So I'm going to do this math and get what 4t is. So, and again, I don't care if you use natural log or the other log, just be consistent. So 1.020625. I think I typed that in right. Nope, I did not. There should be a 2 there. So I write 1.020625. Okay. And I'm going to hit enter. So I get that 33.95. And again, you don't round to the very end. All right, so then that's what 4t is. So I just have to divide that number by 4 because I want to figure out what time is. So I'm going to divide by 4, and I get this. And time is always annually. So it depends on what they want. You know, if they say round to the nearest 10th, then I would say it's going to take about 8.5 years for that money to basically double, right? To go from $10,000 to $20,000 is doubling. So that's why when you divide, you get a 2 over here because your money went from $1 to $2. Basically, it's doubling. So it's going to take about 8.5 years. All right. So that's kind of how you can use logs, is you can fill out everything, do the math inside here to get the exact multiplier, divide by the coefficient to just get it so it's a base, exponent, answer. And then remember, log of the answer, divide by log of the base, will always spit out the exponent. And that's how you can solve. Otherwise, if you don't want to do that, no problem. Just guess and test. So, right, like up here, just do 10,000, you know, parentheses, 1 plus 0.0, what is it, 825, divide by 4. And then guess, you know, 10 years. So that would be 40. Okay, so do you see how 40 is too high? So 10 years is too high. And on my calculator, I can do second entry, right? And then I could just edit this. So I could say, okay, well, what about 30 years? That's too low. Okay, so then I could do second and, oh, shoot, well, not when you do that. Let's see if I can, there we go. So maybe I could do, okay, I know I'm going to multiply by 4, right? So I might do multiples of 4, so like 32. Getting closer, second entry, I might do, let's see, 36. That's a little high. So again, 36 divided by 4 would be what, 9 years? So then, you know, if my math lab wanted years and it rounded to 9 years, I'd be fine. Or if I did 8 years, I'd be a little under. So then I might guess 8.5 or something like that. So you could do guess and test. It's just logs are super nice. All right, hope that helps. Good luck.